acidic character of the substituted phenolic compounds. So these are some phenolic compounds. Phenol, this is the nitro group, this is the Cl, and this is the Me, this is the methoxy group. So these are the group is attached at the para position of the phenolic compound. So this is the para position of the phenolic compound. So we can see, and here we have to find out the which of the following phenolic compound is more acidic in nature. So if you see here, this is our standard phenol, but here this is the NO2 is our electron withdrawing group. So we can write here NO2 is having which one? This is having the minus I effect, electron withdrawing group is due to electron withdrawing group minus I effect, and this is having a minus R effect. So both will withdraw electron at the this downward positions. Now if you take a CaCl, so if you take Cl, what will happen? So they have also minus I effect because they will also withdraw electron towards itself, and plus due to lone pair present on the chlorine, so they will also give you plus R effect here. But here one more possibility that Cl is having what, 3p orbital, and here carbon is having 2p orbital. So in the 3p 2p the orbital overlapping is ineffective. You can say the orbital overlapping is ineffective. So in this case what happened, minus I effect is more. So here 2 effect minus I effect minus R effect, this is minus I effect. And the phenol is our standard, so we can write here phenol. So phenol is acidic. Okay, so no I effect is there, phenol. Next is our methyl, so Me. So if you take Me, what happened here? They have hydrocarbon. So hydrocarbon has, you can say they have positive effect, so they are the electron donating. So they are the electron donating group. So they will give you electron will be pulled upward. So they will give you more basic characters. Here we have more plus hyper conjugations. So here plus hyper conjugation is more, we can say more. So they are having plus I effect. Okay, so they will increase the basic character. If you take here OMe, so in case of OMe what happens here, due to oxygen, so they will withdraw electrons, so they will having here minus I effect. So here they will having minus I effect, but oxygen having a lone pair. So lone pair means they will again donate electron to the ring, so they will having plus R effect in the ring. So what happened, due to this plus I effect, what happened, electron donating character will be more than hyperconjugation. Here electron donating character will be more than hyperconjugation character. So we can write here plus R effect is more than the minus I effect here. So in both cases what happens here, plus R effect is more than the minus I, but in here hyperconjugation is more than the I. But out of this, here electron donating is more. So we can say out of here, in case of Me and OMe, in these cases this having a more electron donating character than methane. So this will be your more basic, this will be your less basic. So out of this we series will goes like this one. So NO2 is this one, so this is your 2, this is Cl is your 3, then phenol is your 1, then here Me is your 4, and then after 4 we have 5. So this is the second, this is the third, this is the first and fourth. So this is the series of the acidic character of this series, So this is our answer. Here we can say benzoic acid, substituted aromatic acid, so here NO2, Cl, Me and OMe is there. So again we can write here this NO2 is having is a strong with electron withdrawing group. So electron withdrawing with minus I is also strong, minus R is also strong. If you take Cl, so Cl is having minus I effect. So here what happens, it has also electron donating character. So this is the withdraw electron, this is also withdraw electron. But here what happens, due to this again this chlorine having a 3p and carbon having a 2p. So electron overlapping is not possible. So overlapping of electron is overlapping orbital is ineffective. So here we can write overlapping of orbitals is ineffective in these cases. So minus I dominates. Second is our carboxylic acid. You can say carboxylic. So this is our standard acid. Okay, now we'll take Me. So in case of Me, there will be your hyperconjugation. This is the electron donating group. So again we can say here this is the plus I effect is there, and again we have plus hyperconjugation effect. So hyperconjugation effect is greater over here due to methane. But if you take OMe, so in case of here we have minus I effect due to this one oxygen, so they will give you minus I effect. But we have lone pair on the oxygen, so due to lone pair on the oxygen we will having a plus R effect. But here overall if you take the electron donating character, so here electron donating is more, electron donating is more due to plus R. So due to plus R, electron donating more. So here also electron donating, here this is also electron donating. So if you take the overall electron donating, so in overall electron donating is plus R is much more than the minus I. In case of electron donating is plus H is not that much more than the plus I. So overall this is more, this is less. So this will be your more basic, this will be your less basic. So ST character will be like this one, 2, then 3, then we have 1, then we have 4, and then we have 5. This is our ST character of this compound. So in this case of substituted aromatic acid, you can see here. So in this you can see here, again you see here. So if you take here NO2, so here this is the standard basic character. So first you take NO2, so NO2 we have how much? Minus I character, this is your minus R character. So in case of ammonia, we will take first basic character. We will take here first basic character. So if basic character is more, so we will take the reverse of the acidity. NO2 we have more, minus I minus R. In case of Cl, so Cl we have minus I, then we can write here after NO2 this is okay. So here again you can say take Cl, no not Cl, Cl we have minus I, then we have plus R due to a lone pair. Then you take here Me, so Me we have what? Plus I, okay, plus I and plus hyperconjugations, okay. Then we take here OCH3, so OCH3 we have minus I, and here we have here plus R, but here plus R is more than the much more than the minus plus HC, okay. So this will be your more basic, and this is our standard. So this is the more acidic, then followed by this one, then followed by this one. So which will be more basic? This will be more basic. So more basic means fifth is our more basic, then followed by 4, that is this one, then followed by 1. Amine is a more basic lone pair, then followed by Me after 1, this is followed by 3 Cl, because Cl having here minus I, this is plus R, and then last is your NO2 is 2. So this is the basic character. So take the reverse of basic character. So SD character will be, SD will be your 2, then 3, then 1, then 4, and then 5. This is the acidic character of this compounds. Here substituted phenolic compounds, OH is given here, Br. So in these cases we will say, in all cases we will see here. So here if you take this one, so this is your ortho position, this is your meta position, this is your para position. So in case of ortho position, minus I effect at O. So here less distance. In case of meta positions, here your this is your minus I effect, but more distance, and here you take here para position, here minus I effect but less distance. Okay, and this is your first case is your standard. So in this case what happens, so minus I is operates through distance. If there will be a more distance, there will be less distance, this will less I. So M position is, so this is a standard. So here minus I operates through distance, so more minus I, this will be less effect. So in these cases we will get here, this is the 2, so 2 will be your more acidic than the 3, then 4, and then I. So actually this is ortho is more acidic than meta, and then ortho, meta, then para, and then your ortho, meta, para, then your standard. So this is our acidic character. Aromatic acid, so here we have 4 groups. Benzoic acid, this is the ortho group, this is the meta group, and this is the para group. So which is more acidic? So in this case we can see here, this second is at ortho position, so here we have minus I effect is more. In third position, this is their meta group, so in meta group minus I effect is there, and para group we have again minus I effect. So in acidic what happens, minus I effect is operates through distance, it depends on the distance. So distance is more, less I effect. So more distance, less I effect. So in these cases, if you see this one which will have more acidic, so 2 will be your more acidic. So in these cases 2 is more acidic than 3, then 4, and then I. So basic concept is here, ortho is more acidic than meta, then para, and then your standard. Standard means benzoic acid. So benzoic acid is more acidic in nature. So we just keep these things in mind. Minus I effect operates through distance.